Hi everyone, welcome back to the Linux. Today we are going to see about K nearest neighborhood. The K nearest neighborhood is a supervised machine learning and used for both classification and regression tasks. And it's also called as an instance based learning because it will learn. It doesn't learn on during the training process. It will predict the output by traveling entire the data sets. On each prediction, it must travel to an entire data sets, and it's also called as lazy learning because it doesn't learn during the training. During the training, it will simply upload the dataset into a memory, and it's also called as non-parametric method because it doesn't have any internal parameters like variables or arrays or functions. During the prediction, it will simply predict the output based on the inputs and the futures in the dataset. How it will works like there is a data set of a thousand, like 100, 1, 2, 3, 4, up to an 100. If there is any new data comes for prediction like x, it will simply find the distance between the x to all the data points. Let's take the distance between the x1 to a data point 1 is d1, and simply the distance between the x1 to a d2, sorry, x1 to a point 2 is d2. Similarly for a d point 3 is d3, for n a point 4 is d4, up to n a d100, and it will choose the smaller value of n a, like it will choose the k smaller value in the distance. What it will do was it will sort this distance and choose the k smallest value, or we can say as it will choose the k nearest point to any x value. Like if the data points are looks like this, if there is an unseen data here, this is an unseen data. If the value of k is 3, it will choose the k nearest points. There are three neighborhoods. There are three neighborhoods, right? There are. It will choose k nearest points, and it will return the majorities of the votes. Like for in a classification, it will simply return the majority votes. For in a regression, it will simply return the average between them. For in a classification, it's like dog, cat, and birds. If I k is equal to 3, I will choose 3 data points like D1, D2, or D30, and D1 it's as in a class 1, and D2 tells I am in the class 2, and D30 tells I am in the class 1. In this case, it will return simply 1 because 1 is majority here. For in a regression task, it will simply average the data data points like D1 plus D2 plus D30 divided by 3, and it will return this value. As I told, it will find the distance between the new data to all the data set in the all the data points in the data set. It will use some formulas. There are three formulas used for calculating the distance. For this, the formula will look like x1 minus x2 the whole square plus y1 minus y2 the whole square plus it is goes like number of variables in the futures, like number of variables equals to number of futures in the input or in the data set. This is a formula for this distance function, and for a Manhattan distance the formula will looks like modulus of x1 plus modulus of x1 minus x2 plus modulus of y1 minus y2. Here also the number of variables equal to a number of futures in the data set. And for a categorical data, we use function called Hamming function, or we also call as Hamming distance. It will simply find the mismatches between the data points. For example, Let's take in a two string S1 like Sanjay and S2 as Navi. Sorry, let's take Sanjay. Here it will end as Y. You know that Sanjay will have an, we can put in a Y, also an I in the end. So the ambling distance between these two is 1, because it will check the first position, both are same, and it will check the both second position, the two string, all are same. It will only differ in the last value because S1 contains Y and S2 contains I. So there is only one mismatches. So it will simply return 1. But for let's take another value. Let's take Naveen. Now the ambling distance is 5 because the first position both are differ, and second position only are same, and third position are differ, fourth position also differ, fifth position also differ, and sixth position also differ. So there is 5 difference in the data points. So it will simply returns 5. So ambling distance simply find the mismatches between the data sets. Choosing K. As I told, it will, in this model, it will choose the K nearest data point to an input data or prediction, uh, the data point we need to predict. So choosing the K is play a crucial role here. For example, if I plot the data points like this, if I choose the K as in a smaller value, it has a low bias and higher variance. For example, some data points are large away from this. In this case, it having a low bias and a high variance, and it will sensitive to a noise. For example, there is a data point. It is far away from the, far away from the variance. So choosing the K, it looks like this. So in this case, it will may not perform well. But for but also the larger K, it will like choosing the data points like this. In this case, it having a higher bias but in a lower variance. And here also there is it doesn't find any patterns or any relationship between the data points, because the K is larger. It may lead to an over smooth. So the choosing the K, it's playing a crucial role. There are two methods choosing the K. One is cross validations and another one is elbow method. I will put another separate video for these methods. And choosing K as an odd is preferred because the if you choose the K as an even, it may lead to a tie. But for an odd value of an K, it may not like. It will never tie the categorical data. Steps in the KNN. We compute the distance from the query point to all the training data sets, because the data sets are looks like 1 to up to 1,000, and the query point is X. It will find all the distance. Sorry, it will find the distance between the query point to all data set. After finding the distance, and it will sort the distance in ascending and select the K nearest algorithm. It's like it will find the smaller distance in the we found the distance between the X to all other data points, or we can say as it will choose the near query point smallest data points, or we can say as closest data point to a query point, and give the output, or give the output as in a majority vote among its neighborhoods. Practical consideration. While implementing these models, there are some considerations like dimensionally higher dimensionality reduce distance relevance. There is higher dimensionality, right? If the number of futures goes in the more than 3, there is a higher dimensionality, right? We cannot plot the graph. Like If there is in a 2D, we can plot it. If there is in a 3 dimensions, we can, it's ought to practically plot the graph. We need to like in a VR, no one do like that. And for in a data points which have in a, for in a data set which has in a more than 3 features, it is impractical to plot the graph. So it has in a curse of dimensionality and computational cost. I- Upon seeing on new data, it will need to travel the entire data sets. Like n is in a number of data points, size of in a data set, and a is in a number of prediction we need to do. And memory footprints. While training, it will simply upload all the data points into in a memory. So it has in a, like we need to store the entire data set into the memory. So if the data set contains thousands or lakhs of data points, we need to store entirely in the memory. Like memory inefficiency. And advantages and disadvantages. It is simple to implement and interrupts, and no explicit training phase because it's in a lazy learner. It doesn't learn or doesn't find any relationship between the inputs and the outputs, and it will naturally handle the multi-class problem. Unlike the linear classification, it will simply consider the one classes as separate and all other classes have another classes. But in the but in the KNN, it will naturally handle the multi-classes. And there is also a disadvantages, computational expensive at a prediction time because we need to travel the entire data set and sensitive to any features like unrelevant to in our models and performance degraded in a higher dimensionality space. When we like have an higher dimensionality data, like number of features will greater than 2, it will find the some performance delay during the like distance, uh, during finding the distance and also traveling the entire data sets. How it will works. For better understanding, we will take some example. There is a student studying some hours and he will get passed or not fail in the exam. If the student X1 studies 8 hours and he will pass, and another student studies 7 hours and he will pass in the exam, and another student he will study 6 hours and he will pass in the exam, and another student he will study in 4 hours and he will pass in the exam. Sorry, he will study 5 hours and he will pass in the exam, and another student is studying 6 hours, sorry, 4 hours and he will pass in the exam, and another student he will study 3 hours and he will pass in the exam, and another student will study 2 hours, he will fail in the exam, and another student will study 1 hour and fail in the exam. Here is the data set. It's like someone during in the class, everyone is studying for an exam. Some of them are studying 8 hours, 7 hours, 6 hours, and another is studying 4 hours, and another person is studying 2 hours. And during the prediction time, like if the teacher if like it's like in a teachers are corrected the paper and one student is missing like or absent, and that student's in a, let's take that is a prediction value xp, and he will study on 3 hours. On the result day he will absent, on the result day he will absent, and he will come on the after the that day and ask the students whether they gave the papers or not. All the students are told that they have given and passed, and some of them are passed and some of them are failed. So these students need to know the whether he will fail or not fail without asking the teachers. Okay. In this case, he will what he will do was he knows how many hours he will read because he knows I will learn this exam for an 3 hours. He simply what he will do was and go ask for this another student how many hours he will study, and he will tell like 3 hours, and the this student asks whether you are passed or not, and he will tell like yeah I will pass, and this student not satisfied by a single person, and he will ask another student like the student X7, he will study 2 hours, 2 hours, and he will fail. And another student like X8, he will study 1 hour and he will fail. And another student, he will ask like X5, he will study 4 hours and he will pass. He will ask another student and he will study 5 hours and he will pass. So so the person want to find the he will predict or not, sorry, he will pass or not. He will simply ask the other students which are closer hours to our studying hours. Like he studies 3 hours, right? So he will ask some people who are study 3 hours or near to 3 hours, 3 hours. Based on the majorities, he will predict we will pass or we will not. Here it case, he is pass. He will study on 3 hours, right? He will study on 3 hours, and he will ask the other students who are studying nearest to 3 hours, like one is nearest to 3 and 2 is nearest to 3 and 4 is nearest to 3 and 5 is nearest to 3, right? He will ask the other students who study exactly or nearly to his or hers and gives the prediction as in a majority. Like in this case, there are three students are passed, right? And only two students are fail. So that students thought like um the majority of students are studied or exactly or near to our studies or passed. Some of them are fail. So we will pass. We will think like that. This is how the model and the intuitions works began. In summary, the KNN is a straightforward instant-based learning because it will only predict the values upon the prediction time. It doesn't learn anything in the training training period. And key parameters. There is key parameters K and distance merits. There is only K to it is only one parameter in this model for choosing a K nearest data points to the prediction value, and distance parameters like Amling distance or Manhattan distance we choose based on the problems, and critical to a scale features, and choosing a K we of in a validation. There are two methods as I told, elbow method and the cross validation method for choosing a K, because choosing a K plays the vital role in this model, and it will always prefer K as an odd number, and effective for a small to medium data set because it will it will during the prediction it travel entire data set, right? If the data sets are small or medium, it will okay. For if the data set which is goes beyond like millions, 10 millions, like that, for an every data set goes it will goes like entire data set. So it will good for a smaller to a medium level data set, and it will have a computational cost and having a dimensionality, and it will works for a higher dimensionality. So it has a dimensionality cost, like we need to process all the dimensional data, and also in a computational cost, that is like we need to travel the entire data set. And this is all about the KNN, and thank you for watching.